All right, so we've been talking about percent, we've been talking about proportions. Now we're going to talk about something that is just a little bit different. It's called percent of change, okay? Percent of change is the percent by which an amount increases or decreases from the original amount. So discounts are an example of a percent of decrease. So for example, when an item is on sale 15% off, and markups are an example of the percent of increase. So a store buys an item for a set price and they charge you 20% more than their price, so they make a profit. So percent of decrease and percent of increase are the two types of percent of change. So we're going to be looking for those phrases. To find the percent of change, you can use a proportion. Follow these steps. Now you're going to see a very exaggerated, we have to make sure that we know what these steps are, that we know where to locate them, that they're very important. Please, please, please make sure that you are making notes on here. Number one, find the difference between the amounts. You need to subtract them. You are finding the change. That's going to be your part or your is number. We are no longer going to just pluck a number out of the question to be your part or your is number. You actually have to subtract to find the amount of change. From there, the rest of it's pretty straightforward. The original amount is your whole, whatever was the original value. The unknown is often the percent. We're often looking for the percent because we're looking for a percent of decrease or a percent of increase. We're going to set up a proportion and solve, and then we decide whether it was an increase or a decrease. All right, so let's do some of these questions so this actually makes sense in context. Number one, a store buys a book for $12 and marks up the price to sell for $20. So the first thing we need to do is find the change. The difference in $20 and $12 is a change of $8. So this is the change, the markup, the change of the price is $8. They changed the price by $8. It went from 12 up to 20. What was the original cost of the book? This is your of number. So a store buys a book for $12 and then marks it up. So the original price was 12, then it went to 20. What is the percent of change? So your part, your difference goes on the top. So we're going to put the 8 over the original 12 equals x over 100%. And now we solve it like any other proportion. So 12 times x equals 8 times 100. Divide both sides by 12. X equals, and it's 66.6 repeating percent. So we would say, is it a percent increase or decrease? It went from 12 up to 20. So it is approximately 66.7% increase. We would want to round it to the tenths because it was a percent. So not terrible. The trickiest part about this is making sure that you get the change, the part where you subtract it, that's the number that goes on the top. So notice we never put the 20 anywhere, right? We're not just plucking numbers out of the question anymore. Number two, a gallon of gas was $4.09 in early October 2008. A gallon of gas cost $2.74 in late October 2008. So first of all, what is the change? So if we do $4.09, take away $2.74, because we're finding out how much the price changed to get our is number, the part, 5, 10 take away 7 is 3, $1.35. The price of the gas changed by $1.35. The original price, it was $4.09 in early October. Then it was $2.74 in late October. So the original price was the $4.09, the earlier price. So what is the percent of change? So we need our change, which is the $1.35 over the original, which is the $4.09. And then we set it equal to x over 100% and solve it just like we did any other percent. So 135 times 100 equals 409 times x. I set it up on the wrong side, but that's okay. If I multiply by 100, I move my decimal point 2 places. So it's going to be 135 equals 4.09x. Divide both sides by the 4.09. And I'm going to get approximately 33. 33 is approximately x. So we can say approximately, or we can use the word about, approximately or about 33%. And it went from 409 down to 274. So we would say this is a decrease. So not too bad once you get the problem set up. That's the tricky part. Number 3, a gallon of gas cost 99 cents in the summer of 2000. How much does a gallon of gas cost today if there had been a 343% increase? So here's where the setting up the problem becomes really important. What is the is number? What's the amount of change? It went from 99 cents up to, and we don't have the later price. So that's the thing we don't know this time. We don't know the is number. The of number, the original amount, was the 99 cents. And then it went up to something else. They did tell us that the amount of change was a 343% increase. That's how I know it went up. Write a proportion and find the amount of change. So I'm going to say X, the is number that I don't know, over the 99 cents equals a 343% increase over 100%. Now we can have a percent that's greater than 100. That just means it went up by a lot. So we're going to say 100 times X equals 343 times, I don't know why I keep writing 344. 343 times the 99 cents. So 100X equals 339.57. Divide both sides by 100. X equals 3.3957. Now, this is supposed to be money. So we would have to be really careful with this and say, because it's money, we'd have to say about 3 point, and the 39 followed by a 5 would round up to 40. So about $3.40 change, or we can say increase. So that's how much the cost of the gas went up. So the gas was 99 cents. It went up by $3.40. So the new price would be approximately $4.39 today. So $4.39 is the today price. This thing that we found over here, the X value, that was the amount of change. The price changed by $3.40. So now it's $4.39 today. All right. Suppose the store's sales increased 8% from June to July and 8% from July to August. So the sales were $8,199 in June. So we want to find first 8% of $8,199. So option number 1 is the proportion, right? So how much is that 8% of $8,199? And we would say 100 times X equals 8,199 times 8. That's your cross products. 100X equals 65592. Divide both sides by 100. And X was 655.92. Now, that number here is our change. The 8% change in the store's sales mean that the sales went up by $655.92. So off to the side, we're going to add the $8,199 plus the new $655.92. So the sales were $8,854.92 in July. So June was $8,199. 8% of that was an extra $655.92. So in July, we're up to $8,854.92. Now, our July sales went up 8% to get to August's price. So we're going to do the same process again, but this time we've got to put the 8854.92 in the denominator and find 8% of that new amount that was July's sales. So when we cross multiply, 100X equals this new larger amount for July times 8. Going to be a little bit messier. That's okay. When I multiply that by 8, I get 7839.36. Divide both sides by 100. I'm going to have to round because this is money. So $708.39. And you'll see I used approximately. So the price change from June to July was $655.92, giving us a new higher total in July. Now, 8% of July's went up by $708.39. So we're going to have to add $8,854.92 plus the new $708.39 to get August's new total, which is $9,563.31 in August. So what's interesting here is that the change from June to July was a different amount than the change from July to August, even though they were both an 8% change. So it says, Harry thinks that since sales increased 8% in July and 8% in August, they increased the same number of dollars each month. Was he correct? We would say no, because the 8% was out of different starting amounts. The starting amount in June was different than the starting amount in July. No, because the 8% was out of different starting amounts. Janine thinks if it was an 8% increase twice, she could have just done a 16% increase. Would this have worked? And we're going to say no right off the bat. We know that the first 8% was not equal to the second 8%. However, if we wanted to take the time to do it and we said, okay, 8,199, what's 16% of that? Okay, so we would do 100 times X equals 16 times 8,199. So the 16 times 8,199 is 13,184. I don't know if I did that right. Let's see. Yep, I guess so. Divide by 100, and X equals, all I have to do is move my decimal point over two places, 1311.84. So what this is saying is if we just did 16% right off the bat, the change from June straight to August would be 1,311.84. If we check the math on that and we add 8,199 plus 1,311.84, 9 and 1, 5. Then you would end up at 9,510.84, and that is not correct. It should be 9,563.31, and that extra $50 and change makes a big difference. So what we would say is no, we cannot just jump to a straight 16%, because that would actually cheat this person out of some money. They actually would have earned more because the first 8% was smaller than the second 8%.